So for the last video of section 2.1, we are going to do an example where we find the equation of a tangent line to a curve. So we are going to find the equation of the tangent line to f of x equals x squared at the point -3, 9. Okay, so let's remember what we're looking for here. We want to find an equation of a line. So equation of a line, there are a couple different formulas that you can use for this, but I'm partial to the slope-intercept form myself. Good old y equals mx plus b. All right. So we are clearly going to need the slope of this tangent line and an intercept value to come up with the full equation. So to remind us how we're going to find that slope, recall from the previous video, for a tangent line, we are going to set up essentially a secant slope formula. This m equals f of x1 plus h minus f of x1 over h. And then we're going to let that distance h approach 0. Okay, so let's set up that secant slope formula. All right, f of x1 plus h minus f of x1 over h. And we actually know what our x1 value is because there's only one point we're given, and that point only has one x value. So this right here, that is x1, -3. All right, so we can put that in. F of -3 plus h minus f of -3 all over h. Okay, and for that numerator, we know what the function is. The function is given in the problem right here. So we're going to be able to figure out what those two terms look like. Okay, first things first, f of -3 plus h. Well, we do have to take that whole entire set of stuff inside the parentheses and plug it into our function. So what this is going to look like is we take -3 plus h and square it. And then we're going to subtract f of -3, which you could plug in -3, or you could just look at the y value on our point. That's going to be 9. And put that over h. Okay, so now we've taken care of the using our function f part. And let's expand out that squared term and try and simplify some things. If we square that out, we're going to get 9 minus 6h plus h squared for that -3 plus h squared part. And then we still have our -9 from before, which is convenient because check that out, the 9s are gone. And we can also factor and cancel an h. Okay, factor an h out of the numerator and cancel it with that h that's in the denominator, and you get -6 plus h. Now, as far as the secant slope goes, you probably wouldn't do this if you were actually given two different points. You would probably just use the classic slope formula, but you could actually use this slope formula even if you had two different points. You would just have to calculate the distance between the two x values of your points and plug that in for h. So that's kind of a nice little trick if you had to calculate a bunch of these slopes, but that's not what we're using that for at this particular point in time. This is just a generic representation of the secant slopes. What we're really interested in is the slope of our tangent line. So tangent slope. We are going to let h approach 0. Okay? And when we do that, the slope, -6 plus h, if you let that h part get smaller and smaller and smaller, essentially go to 0, we end up just getting a slope of -6. And that is the slope of our tangent line. Okay, so the slope of the tangent line is m equals -6. Okay. Now, some questions, I believe, on your homework will just ask you for the slope of the tangent line, and so you would be able to stop at that point. But this particular example is asking us to find the full equation of the tangent line, so we've got a little more work to do. All right, not too much more, though. The bulk of the work is done. Equation of the line. All right, we're going to use that slope-intercept form, y equals mx plus b, except now that we know that m is -6. Okay, and then just a little refresher on how to find the equation of a line. Recall that we've been given our point, -3, 9, so we're going to use that. And y coordinates were -3 and 9. So we plug those in. Y and x. And then that's going to allow you to solve for your y-intercept, the b value. Okay. So we have 9 equals 18 plus b, telling us that b must be -9. And so now we'll have our equation of the tangent line. Y equals -6x minus 9. Okay, so that is how we find the equation of a tangent line.